Greetings, this is Artie from Artifact Electronics. In a recent episode, I had borrowed some Atari Coinop PCBs from a friend of mine, and there were two missile command boards. We went through how to set them up, diagnosed them, and fixed them. And when my friend found out about that, he was so overjoyed that he had to give me some more boards to look at. And what I got for today's episode is two boards for the Atari Liberator Coinop game, which came out in 1982 and was a follow-up to Missile Command. Now, just for comparison's sake, Missile Command sold approximately 18,000 units across all cabinet flavors, and Liberator sold 762 units, and obviously had a much shorter lifespan. It is a rare game, coveted by collectors, and but obviously the gameplay leaves a bit to be desired because Atari obviously cut production short on this unit. But let's see what we can do, and if you've seen the Missile Command demo, then I'll be interested to hear your opinion about why this game didn't sell very well. Now you might recognize the setup from my Missile Command repair. We have the power supply units, which consist of the transformer in the back and the regulator audio amplifier in the middle there. I do have the Liberator board hooked up, but you may remember last time we didn't really have any controls and weren't able to play it. But what I've done or gotten this time is, of course, we have our old interface to the LCD monitor, but what we also have is a trackball and a small button panel, which actually allows us to play the game when and if it starts to work. The issue is I hooked up the game, I double and triple checked all the connections, I measured voltages on the board, but the board would not come on. So let's do some tests on it. So let's see what happens. I apply power, power LED comes on, but this is what we get. So we see part of the earth in the middle of the screen and garbage lines all around, which leads me to believe that the clock is running, because the clock is usually shared by the processor and the video circuitry, or derived, different clock rates are derived from a single clock source. And so the video is running, so the guess is that the clock's good. But let's see if the processor's running or not. And you can see there's some test points next to the processor. And what I'm going to use today is the poor man's oscilloscope, or a logic probe, which looks like this and simply shows you the state of digital pins. And the reason I'm using this is it's really not necessary to use a scope here, at least not yet. So if we look at these test points here, going through them, this is the read-write pin, and I should probably zoom out a bit so you can actually see what the probe is telling us. How's that? Not good. Need a little more here. So probing the read-write pin. Okay. It's basically saying that the read-write pin is high permanently, which would indicate that there's either no activity at all from the processor, or it is, or there's a ROM problem or whatever. Anyway, the next two pins are phase 0 of the clock. We can see that that's pulsing. We don't know exactly what it's doing, but since it's pulsing and the monitor's showing a picture, we can assume that that is probably correct. We go to phase 2, which is just a 180 degree out of phase signal for the 6502 clock. That also works. And then they also brought out the reset pin. And reset is permanently low, which means the processor is being held in the reset state. So what we need to do is let's have a look at the schematics and see what reset, or what's holding reset low. So here's the reset circuitry. Essentially a power good signal that comes through, and while power good is still low, it disables this counter, 74LS197, configured as a 4-bit up counter that is presettable. And so initially, while the power good signal over here is low, the reset signal, which is QD, stays low. Now once power good goes high, this clear signal essentially disables the counter. Even though a clock's coming in when the clear signal is low, the counter doesn't do anything. It just, all the outputs are at 0. But once the signal goes high, the clock starts clocking this thing, and after 8 of these clock pulses, QD will go high, and QD is the reset signal fed to the processor. And under normal circumstances, everything should be just fine. But then you may ask, so what happens when the binary count wraps from 1111 to 0? And that's the purpose of the watchdog circuitry here. And what that basically does is the processor generates a watchdog signal, if it is running properly, and in the not probably, but in the interrupt routine, it gives a watchdog pulse to this, and what that causes is for the counter to load its data, which has QD, the D input set to 1, which makes sure that the QD input stays high and everything goes as planned, i.e. there's no reset signal activity and the processor just continues to work. The purpose for this is if the processor jumps off its tracks or is executing garbage code, it won't be able to generate the watchdog signal, and the watchdog signal will be allowed to basically let the processor wrap, the counter wrap from all 1s to 0s, and that'll start a new reset cycle through QD, another 8 clock pulses of 128V. So it's actually giving the system a chance to reboot cleanly. But what happens most times, once the processor's in bad shape and won't be able and doesn't generate the watchdog signal, the processor is pretty much held in reset, and the game doesn't run. So what could possibly be wrong here? So a bunch of things can go wrong here. I was sitting staring at this. Component failure in here is obviously the reason why this isn't working. But then I noticed something that for some reason had escaped me earlier on, and that is in the power good circuit over here. I'll cut through the chase here. For some reason I thought that the power good was monitoring the 5 volts, but it's not. It's monitoring the 10.3 volts unregulated, and the comparator is also powered by that voltage. And the way it works is we got a 5-volt Zener over here, and with these dividers, the voltage initially, the comparator input, will always be ahead of this comparator input, because this is going to rise higher and this has a voltage divider in it. But eventually this diode will clamp this input at 5 volts, and this one's just going to rise higher. And eventually this will exceed this, the output will go high, and that's your power good. So what does all of this mean? What all of this means is that I have made all sorts of connections here on the board, as you can see, running at 12 volts, minus 5 volts, and all of that into the board. But I haven't run the unregulated 10.3 volts into the board. So essentially that comparator, well, works just as expected. It never raises the power good signal, because as far as it's concerned, there is no power good in there. So what needs to be done is the 10.3 volts unregulated needs to be connected from the regulator board over here to the PCB, and it turns out that the reason I probably spaced this is the PCB does not have a test point like these for the 10.3 volts. Now from the schematic we know that it's going to, let's see, pin 8 on the op amp and also R119, but we got to find out which side of R119 it goes to. And if I probe pin 8 on the op amp, and here's R119, that gives us a 0 ohm connection right there. So this is where the 10.3 has to be attached to. So let's see what the system does now. And here's power. And it looks like the game just came up. Move this a little bit so you can see it better, but there it is. Liberator. Yeah, so that was obviously a user error. But I got power, I got the power hooked up correctly, it comes up, and I have sound connected to it too. So let me change angles a little bit here and see if I can actually play this game. And I'm sure I'm not very good at this game. I don't even remember playing this in 1982. And so let's see, let's use the newly brought trackball and the switch panel I made. And it's set to free play. So let's hit the credit button. This is the credit button, and this is the fire button, and this is the shield button. So there's my bases. The trackball seems to work, even though the rollers seem to be a bit worn out on that. But I was supposed to kill all of the scouts. And there's Mother Earth. And the red spots are the missile batteries that are trying to destroy me. And my shield was too late. My shield was still too late. And where are the missile batteries? Hello? There. Well, I have one ship left over. And they're flying flying saucers. Don't worry, I probably won't last too long here. That squeaky noise means I can't shoot anymore, and there you go. I warned you, I'm not very good at it, but the game seems to be playing. And one other thing I have on my control panel is a test switch, and that is a latching switch. So I'm going to turn that one on. And it sits there for a while, and oh, then it monitors the buttons. So let's see, what do I have hooked up? Oh, that's the fire button over here. This is the shield button. That's interesting. The shield seemed to work, but it's not working now. Oh, that's why I couldn't play. The shield button is the yellow button, not the black button. Coin, left, right. I don't think I have those hooked up. And it thinks it's an upright game. There's some other options here, but I have to close the slam switch, and I don't have that one hooked up. So that lets you adjust the screen and stuff like that. But the screen looks pretty good to me the way it is, so we turn the switch off and go back to the regular attract mode. Alright, and now remember I said we have two boards, so let me get the second board and this time hook it up correctly and see what kind of work that one needs. So board number one works. I marked it over here, and let's have a look at the second board, and let's see if I can at least hook things up correctly this time. 10.6 or 10.3. Power connections. Sound. Power for the trackball. And of course the edge connectors. And here is number 2. Edge connectors. Ground and power for the trackball. And red wire, which is 12 volts DC, and the 12 volts goes. I'm actually not using the test connectors because they're a bit confusingly marked, and so what I did was I found capacitors to connect them to, and it connects a little bit more securely to those. And then we have -5. The ever important 10.3 to the bottom of R119. And sound, which is kind of hard to get wrong because the sound test points are marked pretty clearly. If I can find them, of course. Audio 1. Trying to touch the other one, but now we're good there. That one is, that audio connector is bent over all the way. Let me see if I can straighten that guy out a little bit. Yeah, I can rip them off. Now, well, I'm going to have to heat up the iron for that. But yeah. Alright, I resoldered the one of the audio connectors here, which I so eloquently broke off. And let's connect the speaker to it. And another thing is I almost forgot there is another power connection here which I neglected to make, and that is a tap of the minus 22 volts coming off the regulator, coming over here. And what that does is it gets converted to a well-regulated minus 28 volts, and that feeds the EROM, the electrically alterable read-only memory. So that's what they used for flash memory in those days, and that I guess keeps the high scores and stuff like that. And that one is right there. So everything's hooked up. Well, the game probably would have worked without that 22 volt connection, but it still is necessary. So let's have a look, see if this one works. Excuse me. And it does. Just like the other one, this one also works. Let's flip it into test mode real quick. And testing some buttons. Guess it doesn't test the trackball. So let's start a game and see if the trackball's good. Well, the trackball seems to work, but it's a little rickety because I think the rollers in it are kind of worn. Oh, come on. Ha, shields work. Oh, wait a minute, we can just play this game with the shields now. Hello? Oh, I have to destroy. Oh, I guess it waits till I destroy all the missile bases. But anyway, looks like it's working. It's telling me I'm a rookie now. It's going to teach me how to kill the Earth bases. But anyway, this one works too. So the results from our today's episode are that we just verified 2 Liberator PCBs that do seem to function fine. It would be nice to test this in a real cabinet, but the chances for that are probably pretty slim, with a total of 762 machines ever made. Now, I'm not surprised that they're both working, because this board has seen, both of these boards have seen very little use. And usually the dead giveaway of a heavily played game is that the 5-volt connector or the ground connector over here will be severely discolored or even burned off, because the games were played so much. Like on Missile Command, you could see that those Missile Command boards were running a lot. And these just didn't run a lot. I guess people took the Liberator cabinets and converted them to something else. May that be Dig Dug or a quiz game or whatever, but people obviously didn't like this game. So at this point, if you think I suck at playing this game, then make sure to click the thumbs up button. But if you think that I'm really good on it, then you can click the thumbs up button. If you're not subscribed, go ahead and subscribe, and we'll see you next time.